what is the data engineering today and why in an era of AutoML AI agents, this role is still relevant.
AI is the new electricity, but electricity also needs infrastructure, and data engineering is that infrastructure.
Now that scope has expanded, where a data engineer is expected to work alongside with those data scientists.
If someone rebrands themselves as AI engineer on LinkedIn, let's say, the question I would ask them is what exactly the work changed for them in their day to day. Patient not having cancer, if you diagnose them having cancer, just imagine the mental impact on that patient because of your wrong results that AI gave you.
As we know, the digital footprint has already exploded, and with the AI, it is even going to be more exploded.
The models are as good as the pipelines that run behind it. So the stakes are just higher now.
Hi, everyone. Welcome back to another episode of Techie Talks with Kuldeep. I am your host, Kuldeep Singh. Today, we are excited to have Meghana with us. Meghana is senior data engineer and having decades plus years of experience. Meghana, welcome to the show.
Thanks, Kuldeep. Thank you for having me here. Um, Let me introduce myself. I have got a decade and more of experience in IT. Really started my journey from from software engineering, moving on to big data and data engineering now. So I've got an opportunity to work on multiple platforms, multiple technologies like Hadoop, Java, and now working on cloud and big data. Worked with multiple functional teams. I was able to build, maintain, and deploy data engineering solutions, and I was able to communicate with the stakeholders, utilize my technical expertise mainly to solve the business problems, really.
Oh, that's very good to know. And I know big data or the data engineering specifically became very important during the data explosion and during the digital transformation. But right now, everyone is just talking about LLMs and Gen AI. I know none of that would have worked without a solid foundation. In your own words, what is the data engineering today, and why in an era of auto ML AI agent this role is still relevant than ever?
I agree with you, Kuldeep. The hype is all about AI and AI agents and Gen AI and LLMs. But although everyone is talking about it and excitement is real, but all the AI is consuming in the background is data at speed, to be honest. And humans cannot check that level of volume of data, right?
Mhm.
So when data which is noisy and not that good data, let's say, assume, and it's fed into a AI model, what happens? It gives a noisy result. So that noisy result leads to wrong outcomes and wrong decisions, which can cost business, trust and money, which is a real harm.
Mhm.
So before moving to AI engineering, I think data engineering is crucial step here because if your data is consistent, your model will work consistently and give a better result. So data is not just input. I would say it is a foundation of every single output that is built on it. That is why in the era of AI, reliability is so important. As AI gets more popular, the cost of bad data outcomes multiplies with it. So the foundation has to be really solid. So that is why the data engineering is very important. For to give an example, let's assume that AI model is nothing but a sports car, which is tech savvy sports car. Would that sport
Mhm.
car work well if there were no roads built or there was no traffic system or rules? Could anybody drive that sports car? Right? So the sport car here is nothing but AI, and the road and traffic rules is nothing but your data engineering in the background. So they are interdependent on each other, to be specific.
Mhm. So you are saying yes, of course, and it is good that there is an AI hype, because as long as there is an hype about the AI, the data engineering will still be relevant. Of course, in the olden days, when I say the data engineer, it used to be more sounding like, hey, you are going to just manage, the ETL part. But now that scope has expanded, wherein data engineer is expected to work alongside with those data scientists, whether it is, developing the model, or also not only the developing, but also the deployment of those model.
And I agree with you. Uh, Although the scope and the branding of the name has changed, but it's,
Mm-hmm.
I would like to quote a data AI researcher here called Andrew NG. He says AI is the new electricity, right? But electricity also needs infrastructure, and data engineering is that infrastructure. Without it, the electricity will not work, right? So data engineering is what happens underneath, making the data accurate, reliable, and ready to be consumed. But AI engineering is what happens on top of it. So building and deploying models that consume the data. So these are two different problems and two different roles. And I agree with you. The data engineers now work with data analysts, data governments. These are different roles under the data, mainly. But AI engineering sits on top. So if someone rebrands themselves as AI engineer on LinkedIn, let's say, the question I would ask them is what exactly the work changed for them in their day to day, because they're still designing pipelines, they're still managing the data quality, they're still ensuring there's reliability. So you're still doing the data engineering. An AI label is on top. That does not change the foundation underneath, right? So the hype makes it look revolutionary. I agree, but the core foundation remains the same, which is the data scalability and reliability. Let's take a healthcare system, right? It would be NHS here, but in India, it's healthcare system. So, if you take a cancer example, you have your machine learning models to detect cancer earlier than the doctors can, and the machine learning model runs on millions of patient records and medical images. I think data engineers spend most of the time cleaning the data, structuring it, and standardizing it before the model could even see it or run on top of it. So if a mislabeled scan in the training data does if the model runs on a mislabeled scan or a noisy data, it would give us a wrong answer, right? It could potentially affect a patient's diagnosis. So that is the impact, that is why the role is evolving. And
Mm-hmm.
models are as good as pipelines that are running on top of it. So the stakes are just higher now.
I completely agree. And to me, even like, this even now becomes more important because, for an example, earlier, the development of these machine learning models was heavy on the coastal side. So there were only few organizations which were spending the energy and they were building it. But because they were knowing around all these parts, uh, they know how to like fix it, or how even in case like the bad output got generated. But now we see everybody is using AI, right? And even if they are now started relying on that result, and if that itself is not correct, maybe they are not even in position where they go ahead and say, hey, yes, this is the problem, and they might be like still utilizing that model and just assuming that the output which they got is the correct one.
This is the problem, right? So you're giving incorrect result, leading to wrong decision making. I would still quote the same example. A patient not having cancer, if you diagnose them having cancer, just imagine the mental impact on that patient because of your wrong results that AI gave you or a machine learning model gave you. It is that impactful. The wrong result can impact the person's mental health. They are forced to believe they have cancer based on a wrong diagnosis. So the impact is quite huge. So I would say it's important,
Mhm.
the data to be reliable and consistent in this scenario.
All right. Let's move to a new dimension, which is like EV, which are like getting very popular into the Indian market. And I know there is one migration activity also which you have done from Azure Synapse to Databricks.
Yes.
So tell me, like, whenever we go all these providers say, hey, we can handle this much amount of the data, we can always process it, it is like near real time. What was that, the breaking point? Why did it fail to scale with your real time telemetry needs?
So coming to the EV case study, uh, I work in an EV manufacturing space where we get data from each charger, and the data is recorded every minute. So there is terabytes of data generated. And with this fast growing data, charging sessions, we need to understand how much energy is consumed, because the volume of the EV data is growing so high, and storing and processing it had become a challenge. We earlier had Synapse, but with the growth and volume of data, Synapse costs was quite high. The SQL pool costs, the concurrency limitations were quite high, and there were also a lot of latency when we were doing large analytic workloads, which were creating like a ceiling the business could not justify. So in order to address this challenge, I came up with a comparative analysis, Synapse versus Databricks, right? So Databricks was able to handle batch and streaming for on larger volumes of data. We have something called Spark, which runs in the background of Databricks, which is nothing but distributed in memory processing, which does your parallel processing, which Synapse was not able to do because it was mainly SQL based. So it had limited parallelism in terms of massive batch jobs. Also, the Synapse was slow and costly, right? But Databricks gave us auto scaling clusters. It could handle thousands of concurrent jobs without any queuing requirement. So per user cost was reduced due to that, and there is high efficiency, in terms of features, in terms of output, in terms of integration with AI and machine learning. We had all the support that we needed in Databricks. So it was a smart move. And at the same time, the cost was halved, the Synapse cost. So it's a good experiment result, really. Databricks is nearly the next gen analytics, I would say, because it's built on Spark and it can handle the large scale data processing really quickly. So it could do batch processing, it could do real time streaming in future. So moving platforms from Synapse to Databricks, it could create a cost. The team had to develop this new skill, and this was a risk factor. So I have factored all of this into my business case, and I came up with an answer based on my comparative analysis. My main goal was to justify, does this long term saving justify the short term disruption from Synapse to Databricks? And the answer came from my experiment, really. We ran a web application with Delta Table, which is in Databricks, and the savings were immediately seen. We had a live test with real numbers and benchmarking, and we got a full-fledged integration. We could save about £2,000 per month, which is
Mm-hmm.
half which was half of Synapse costs. So I did not just lead the technology. I presented it to stakeholders with real numbers and evidence from my proof of concept. So we could overall save 40% in the cost. We could have faster batch processing with immediate effect. And the message was simple: faster insights, scalable platform for future AI analytics needs. So
So that's very interesting. And yes, of course, and the technology move is one thing, but from your business stakeholder perspective, they are more worried about the business outcome. And as long as you are able to get them the same answer within like a half of the cost, as well as a better result in terms of like the response time, etc., this is very good move. All right. I know the outcome might sound very good and the stakeholder were happy, but if we look at the technical implementation, this I am assuming wasn't just clean like a lift and shift. So I don't know what were the specific, but I'm sure there might be, some stories which might have become like a nightmare during, the cutover. Either it is the data consistency or how you are managing, the data catalog where your upstream or the downstream application were connecting, and including the schema drift as well.
I agree with you, and it was not a easy journey with 10 terabytes of data. It's not a clean lift and shift. There were schema inconsistencies that had impact that had to be resolved. And if your data kept coming in inconsistent formats, that it would lead to your reports to stop working, right? Because the data is not inconsistent. So that had to be resolved. Thanks to Databricks, we were able to resolve, and we could implement the schema evaluation policies, which could automatically adapt to these changes without breaking any downstream pipelines for every new device that was included or every new firmware version that came through. We have something called data governance, which we have implemented using Unity Catalog, which moved our system from legacy role-based access control to a unified data governance model. So you define your rules in a Unity catalog, and then you migrate the compute mainly. So I've done the experiment other way around. The value
Mhm.
came from committing to a full governance infrastructure. This was possible because I could hide the sensitive fields, mask them before it could go in a pipeline as an input. So this was a mid implementation. We were defining policies, we were defining tags, all of that. This approach worked really well with a small scale data. And after the experiment, we have implemented it full fledged towards the entire platform. So, yes, we could handle it using Unity Catalog, I would say. On streaming versus batch, really, we were running the batch processing. We are batching the data as it comes for a period of time, right? So we had to do scheduling, we had to do tracking, we had to do tariff integration. So all of this we were working out along with Unity Catalog and data governance policies.
There is another component called the Photon engine.
Yes.
Did that also came into the picture somehow?
So Photon engine is nothing but your high performance query engine that is built on top of Databricks. It's nothing but your compute really. So when there are large analytic workloads and when there is huge data, you want
Mhm.
the compute or your configuration to scale up and match that level. So you
Mhm.
need the right compute cluster, and you need to enable Photon. You need to identify the workloads that benefit from this change, right? So it is not just like checkbox that you take, but there is a lot of learning that you need to do about how the compute is configured, what are the benefits, all of that you need to consider, because you are actually going to run this on millions of records of data, which is, if your compute is not that good enough, your processing can go slow. So it can impact your output. It may not have good performance. So Photon is mainly used for machine learning, to be specific, but we could use it for data engineering as well.
No, very, very interesting. Also, right, one more thing which you have enabled during this journey was enabling those self-service insight without Power BI.
Yeah.
As a data engineer, how much metadata heavy lifting was required to make Databricks Genie accurate? Even we know today, right, the AI hallucinates. And how did he ensure a business user getting a Genie answer correct to the what he used to be with those Power BI insights?
So the challenge with Power BI is first the license cost. Second
Mm-hmm,
challenge is integrating with the data. You need an external
mm-hmm,
connect to the Power BI. And then you need,
mm-hmm,
and it has a data limitation. You cannot run Power BI beyond a certain limit on data, the report gets stuck. So this is a real challenge with Power BI. Apart from that, the licensing cost was a headache for the business. So I've come up with AI BI dashboard, which runs on top of Databricks. It is nothing similar to Power BI, but it is like a outline layer on your data. So
Hmm.
you develop the similar, maybe not as good as Power BI in terms of functionality,
Hmm.
but it is still passing the message on your KPIs.
Hmm.
So you build the BI dashboard using the Databricks. So you don't have to, always worry about the connector because it's sitting on top of your data. So that makes it smooth and seamless integration. Uh, Another feature that Databricks gave us is Genie, right? Genie is nothing but a chatbot on your
Hmm.
data. So you configure a Genie space, you add your data to it, and you give access to business user. Now, business user can ask their own question to Genie, like how much energy has been consumed in last 1 month. What are the energy specific KPIs they want to answer? So we upload the relevant delta tables in the background before giving it to Genie to the business user. So we write descriptions, we define our limitations, we write the specific questions that the business user can get prompted to ask. So we do all of that configuration before sending it. So that really benefited the business user and saved the Power BI
Hmm.
licensing cost as well.
Yeah. And I think the biggest problem which you solved is like you gave, the power into their hand, right? Because right now, even if you go with like Power BI or any other tool, the one problem after some time it becomes is that those static dashboard, which means I need to ask to an analyst if I wanted to change something, and then again gets back into some work and all. With the Genie and with this enabling where the people can query those or ask those questions in natural language, and they can get those input, and then they no need to be always static, because if tomorrow there might be some other question comes which no one has probably asked, either the question is coming from the user side or from the business side, they can answer it. And second thing is no more kind of the data sync issue or the data is not correct, etc., because you are sitting on that up to date data, and the answers are going to be the almost like correct and instant from the response perspective.
Yes, I agree with you. The business user sees the benefit. It saves a lot of their time because their time is quite crucial. You agree. So the business leaders benefit from it, and the dashboards are live. So you don't have to keep adding an external connector each time because it's synchronizing in the background. We could also add a SQL catalog, which is your SQL
Hmm.
database connecting to the Databricks using a connector. So that way you can build your dashboards on SQL tables, combining with your Databricks Delta tables and give a unified view to the business. It's really understanding what the business wants and what the use case is and how we develop it. And once we develop the dashboard, it is automatic and live. So this is the real benefit and power that I felt is useful for the business user, which could save us time because the analyst doesn't need to go and keep changing the Power BI report each time because it's automatically updated. The numbers are accurate because of the business logic that we have defined in the background. So it is really a benefit to the business user or the data leaders.
No, and I think, see, even with this move, you moved them into the new tech stack and the new ways of working. For example, if they would not have taken this path, probably like the Gen AI, or how now in the future the agentic AI is going to be one. Their data layer is going to be the more stable and more up to date. But tell me one more thing, and maybe like some of the leader who will watch this episode, they get excited. Hey, we also need to do it. Might be they are just using the same tech stack or the different, but if they are hitting the same issue before even attempting a migration like this, is there any technical debt which they should clear first?
I think the technical depth that they should clear is check the data quality first before making a migration. Because once the data is reliable, then you can add your data governance, which is your Unity catalog, on the ongoing data. You do not touch your compute layer unless your data is clean, because the numbers can go wrong. Migrating can improve the infrastructure, but you will hit the cost target. But the analyst will still make wrong decision if the data is not reliable. So the sequence is first get the data quality right and then move the infrastructure. To save some time and risk, we could do a experiment on a small scale data to like a POC to prove the business why this could solve the problem. And then once the evidence is right and the numbers are right, then commit to the full change. But first, audit and make your data quality first, is what I would say. And once you get confidence with your experiment and you get a stakeholder approval, then the return on investment is not just paper, right? It's a trusted decision as a result. You want to give user benefits, like you want to reduce the per user cost and reduce it, drop it to half maybe. You want to make trusted dashboards, trusted KPIs that business can rely on. So the result of this, or ROI, I realize, is both cost saving and better decision making, not just infrastructure migration, is what I think.
No, you are right, and you are like asking everyone to move into the direction. Hey, even though this decision is data related, you need to have data to prove that the decision itself which was taken is right, because no one is just going to hey, pick up, we like B and we should make the move. And they can also make this decision, for example, during this technical debt, if they found might be like the earlier data collection etc which they were doing at this point of the time, even they are not using it, they are just kind of in occurring course, so that cleanup etc also happen as part of the analysis. Okay, tell me something about the EV data landscape itself, because see, I know like this industry is new, specifically in the India region, but overall from the data landscape perspective, also are there like some changes coming? Are there like some architectural etc. which are getting added to make it like the best use of the entire data? I'm assuming the data itself will grow with this as the EV industry grows.
I agree with you. The EV is a new industry for us, and the data that we consume is quite high because you're monitoring each charger transaction per minute, and that's terabytes and gigabytes of data. That's huge. So there should be a right way to handle this, and the I would see the population moving towards EV quite fast because of the demand right now. So it's a two-way process. And the future of EV is not just data engineering and AI. It is more on vehicle to grid. It's more on vehicle to home technology. It's more on bidirectional charging. It is nothing but two-way charging. So you charge your EV when the prices are low, and then you use your EV car as an inverter to charge back your home. This is the future of EV. So the energy is flowing in both direction, not just one direction. So you're integrating with solar, you're having live grid signals, you're having dynamic tariffs. So you're really saving the costs and getting the benefit out of the EV. So the infrastructure that we are building today is going to be as intelligent as possible. And this is the most exciting part of the work is ahead, which is bidirectional charging, which is vehicle to grid charging. So that is really exciting on how fast we are moving. And as we progress, we would also improve our data engineering, we would also improve our AI strategy to handle that level of volume of data. We would develop better infrastructures, we would develop better way of handling the data parallelly before this change happens. So yeah, that is my final word.
No, you are absolutely correct, and I think I don't know about the audience, but I am really excited about this specific EV changes, but in general also about like the overall where the data engineering is heading towards, and it is becoming more and more important in the AI world. So, like, let's say if you need to start your career again in the year 2026, or maybe someone who is just aspiring to become a data scientist, what will be the your key piece of advice to them to prepare for the future?
I would say get an understanding of data engineering principles, the architecture, get that background or domain knowledge in the industry that you're targeting. It is very fancy to become an AI engineer these days, but it's not as the hype in the LinkedIn, you know. It is the basics needs to be right. The foundation has to be right. So you need to understand the software principles in the background, the data engineering principles, how data quality is achieved, how the data is made useful from the bronze, silver, gold layer. So this is the architecture that we work. So the bronze is your raw data, right? You just consume the raw data from any system. Your silver is your data aggregation layer where you aggregate and bring the value in the data, the raw data in the silver layer. And the gold layer is nothing but the insights view, which goes to the business. So this architecture you need to understand how to develop these kind of principles, how to implement Unity Catalog or any data governance, what are the GDPR policies on data, whether you need to mask their data. In industries like healthcare, where data is sensitive, the patient records are sensitive, you need to understand how to handle, how to implement those policies, right? So all this comes in as a package, as a data engineer. And then AI is just cherry on top, I would say. You need to just learn how to build those machine learning models or LLM, or learn agentic AI course to enhance your skills. But data engineering is mainly the foundation. So anyone who's aspiring to be a data engineer or AI engineer, I would say get the foundation right, get the concepts right, understand how it work, and then decide which field you want, because these are two different fields you could choose.
Yeah. No, you are absolutely correct. And even though I see, like, the more and more focus would be on the AI, as long as you are clear about these principle, you can always go back and find, hey, where is the error? Where is this hallucination coming in? Hey, why is this output we are not getting correct? Why it is like, the machine learning model is heavily focused on this feature rather than the another feature? Why is AI not predicting what I'm thinking or I was thinking in my head when I started the project? So all these questions become even much important, and you can always answer them when you know your basics of the data engineering, whether it is related to the data pipelining, data cleaning, then, like, the data massaging and all. And also, as we know, the digital footprint has already exploded, and with the AI it is even going to be more exploded, because even the one LLM calls, or if you are using multi uh, LLMs, then all these calls from where the data is picking it up, where it is updating, whether it is keeping it temporary, or whether the changes, etc., it is making permanent, will even becomes more important. So I feel this overall, the data engineering is still relevant, and I think it is going to be even more relevant in the future.
Yes, and I would say the models are as good as the pipelines that run behind it. So the stakes are just higher now.
All right, then. Thanks, Meghna. Thanks for joining us. It was very insightful discussion, and you shared it very well. Hey, the data engineering might sound boring, but there is like lots and lots of exciting stuff which is happening, and the industry is keeping up to date. And even the engineers are building so many new and smart things on top of it.
Thanks for having me, Kuldeep, and thanks for the opportunity to speak about my experience and my journey.
That's it for this episode of Techie Talks with Kuldeep. Until next time, keep learning and keep innovating. Thank you for watching.